do you have already any information about the software, or should we begin, or should we start really at the beginning?
I would say at the beginning.
At the beginning, okay, good, perfect. So, okay, first of all, I would prefer to start with Caneco BT. I changed the language here to English, so I think it's more clear for you.
Okay.
We start with a new project, and as you can see here, we can different manufacturer files. So the first important thing to know is that Caneco BT is certificated regarding the Senelec standards committee. So Caneco BT is calculating regarding the international standards like VDE, also like the I'm sorry, but I don't know the Italian standard very well, and the IEC standard.
Okay.
Regarding the manufacturer catalogs, we can choose,
one of the sorry if I disturb you.
Yes.
Do you have also implement into this system the UL standards?
No, the UL standard is not available right now, but we are working on it.
Okay.
So the American, the North American standard will be added with the upcoming versions, but right now it's not included. You have the possibility to make short calculations, small calculation with 60 Hertz, like in the US standard, and with these voltage levels, but it's not the full standard, of course.
Okay.
So, if we take a look on the manufacturer catalogs, we see here it's much. It's on my computer, of course, mostly the German and the Switzerland catalogs, but of course there are also Italian catalogs available. And you see here it's beginning at ABB, Eaton, General Electric, Hager, Legrand, Melingeron, Möller, Schneider, Siemens, Terasaki, Unelec. And we have, of course, new catalogs like here Siemens 2017. But also old catalogs, ABB 1990. If you have existing facilities, existing systems, and you want to recalculate them, or you have an existing system and you want to add a new part to an existing main switchboard, so you have the possibility to choose also the old components.
Okay.
Okay, so let's start. And first of all, we have the possibility to add, of course, somewhere our network has to begin. And this source, we have different possibilities like a transfer, a genset, an existing board, or a DC network. And let's start with a transfer. To calculate the connection, it's necessary to know two parameters. The first parameter is the power. What power do I have on this transformator? We can choose here in the standard values, but we also can add a new value up to 5,000 kVA, up to 5,000 kVA per trafo. Okay. And we can add 6 of them in parallel for one main switchboard.
Means, but this was one of the questions last time. This means that you can only have transformers in parallel, or you can manage in the same project more than one transformer?
You can manage one normal supply and one emergency supply. Each of them can include up to 6 trafos and up to 6 gensets. So it's possible to make a normal supply with 6 transformators and an emergency supply, for example, with 3 gensets. If you want to include it on different points, that's possible, yes, but only one normal and one emergency supply. But there are different options. I will show you later. We also handle complex structures, like in the airport Frankfurt, and there we have a few transformators, a few gensets on different points in the network. So there is a solution, but you have to know how you can handle this, of course.
Because typically my project has one medium voltage cabinet with several transformers, typically 7 or 8. So I was asking myself that in that case, if I have to open a project for each transformer, or if I can have and manage all these 7, 8 transformer, which has different consumers in the same project.
Yes, then I would prefer another way. Okay, we're jumping a little bit right now. In Caneco BT, it's the low voltage calculation, of course. We also have the Caneco HT, and I just opened a project, an existing one, so that you see what I mean. That's an middle voltage or a high voltage beginning, 63 kilovolts, down to 20 kilovolt, and so on. In Caneco HT, and this one, we can create your middle voltage network with the 7 or 8 trafos, and we can create different low voltage main switch boards. We can calculate in this software the short circuit currents on the different main switch boards, and we can use this calculated values for the calculation in Caneco BT.
Okay, this is to calculate the medium voltage and the remaining portion.
Yes, and the short circuit currents on the 400 volt level on the low voltage.
Okay,
and, I would prefer to make different low voltage projects for each main switchboard, but the connection between the main switchboards in the middle voltage area would be the best to do it here in Caneco HT.
Oh, okay, this is not a problem. Let's say normally my takeover point are the transformers.
Okay, perfect, yeah.
So it looks like that means that I can handle from the transformers and downstream, I can handle with the Caneco BT, having different transformers in the same project, even if those transformers are not in connected in parallel, correct?
Yes, yes.
Okay.
Okay.
Yeah, just go ahead.
So, okay. The first we enter here is the power, of course, and I gave here a cable length of 15 meters or whatever. And we choose also a protection device for the main switchboard, like an ACB circuit breaker. And if we calculate, the software opens the catalog. In this case, it's the Siemens catalog, and shows us the available components and only the available components. So with an ICU that is enough to handle this transfer, and with an rating high enough, of course. We can choose one of these components here, and you see that the values are changing with each protection device I choose. The first one is normally the, how can I say that, not the cheapest one, but the best one. The fitting, the most fitting, because it has the deeper I go, the more expensive they will be, because there are more options. And the first one is normally the most efficient one. So, we validate, we will see here our project right now. And here, of course, we have our supply, the protection device, and the main switchboard. On the main switchboard, I create a new circuit, for example, a board. It's a connection to a distribution board downstream. And for this connection, I would prefer to have a consumption of 250 ampere or 250 kilowatt. kVA, don't matter. You can enter each electrical unit. The software will change it for you, so you don't have to calculate it by your own. You can enter the consumption here.
Just one thing, in case I do not have the short circuit value at the beginning, is there a, yeah, okay, it calculates based on the transformer, so this means that it considers an infinitive power on top of the transformer in this case, or?
Yes, you have, just a moment, I calculate this, okay, cross section. On the transformer, you have additional data, and in this additional data you have here the minimum and the maximum short circuit power, and this power will be used to calculate the short circuit currents of this transformer on secondary side, so on the low voltage side. Of course, so if we change these values, also the short circuit currents will change here. Is this your question?
Yeah, basically yes, but okay, I can force that values to some very high values in case I miss it. The HV network, I mean.
Yes, you have the possibility to change it here. Yeah.
Okay.
Okay. Here I already calculated, and of course Caneco BT is calculating the cross section for us. Regarding the installation method, it's in German right now. I'm sorry, because of my German setup. It means on cable tray, and we also have a group factor. The group factor is the worst one for this installating method, but I can change it, of course. So if I have two additional circuits on the same cable tray touching each other, I will get a group factor of 0.82. And if I apply this factor and calculate again, yeah, we have another cross section here with 120 square millimeters.
These derating factors can be set for the project in a unique way, or really you have to go one by one at each cable calculation?
These factors here? One by one, but if you have more than one circuit, I would prefer another view on the same project. Show you what I mean. We have here an Excel-like view, and you have here also the factor. So, for example, if I have another factor here like 0.88, for example, it's possible to copy and to pass this value for all the other circuits. So it's a faster way of editing.
Okay. So basically, you mean you make the structure first with the schematic view, and then exactly. You have a fine tuning of these factors in the Excel page.
Exactly.
And when it breaks, means you have to review the sizing.
Yes. You have also a third way. You can export with an additional module the project to Excel, to Microsoft Excel, and you have the possibility to change in one big Excel file all the circuits of your project, all these parameters, and import it back to Caneco BT.
Okay.
Because in this view, you only see the content of one board. You have to to select what content do you want to see of which distribution board. But in Excel, you will see all in one table.
Okay. So when I would have more transformers, I would see on the left more MSBs, correct?
No. If we have more transformers, they are all on the same MSB. So, for example, make the constellation 1 in minimum and 3 in maximum transformers. That means we have here 3
but those are in parallel.
In parallel, right.
If I have different cabinets, back to my issue before, if I have different cabinets, then I would have to have different MSBs.
Yes, different projects.
Then, yeah, that's the question. Then I have to have different projects.
Yes.
One for each transformer.
Yeah.
If not in parallel.
It makes sense because if the projects are really big, and you have, for example, 1,000 circuits on the transformer 1 and 500 on the transformer 2, from my point of view, I would prefer to split the projects because it's easier to handle. One big project is yes, you can handle it, but it makes more sense to create a few little projects, you know. It's easier for printing the documentation, it's easier for searching different circuits, and it's also faster for the calculation.
Okay.
In this case right now, what I have created here is 1 trafo in minimum and 3 trafos in maximum. So if I take a look on the short circuit currents, you see here the minimum current is 11,000. It's from 1 trafo. And the maximum is 40,000. It's from 3 trafos.
One second. I did something. I have to make it small. Okay. Sorry, I had this table in front of. Okay, please just repeat the last.
No problem.
Short circuit,
yes.
yeah.
The minimum values are from 1 transfer, 11,000 or 10,000 ampere. And the maximum short circuit current, 40,000 ampere, is from all 3 trafos here. So that means if I calculate these 4 boards here, the protection devices of these boards can handle all 3 trafos for the maximum short circuit current, and they also recognize the minimum short circuit current of 1 trafo for the tripping unit. So this protection device right now can handle all constellations of here. You see, 40 kilo ampere in maximum and 7 in minimum. Okay. So I create a new circuit here, for example, socket. Of course, it's a final circuit. And on this final circuit, I can enter, for example, 500 watts for each socket. And I have 4 of them. 4 sockets for each 500 watts. If I have more than 1 consumer, you will see 2 different lengths here. The first is the total length of the circuit. It's, for example, 40 meters. The second one is the distance between the protection device and the first socket, maybe 25.
Okay.
So Caneco is choosing an C circuit breaker. It's a 30 ampere breaker here in this case with RCD 30 milliampere, so that we don't forget about it. And we have a 2.5 square millimeters cable calculated regarding the standard. A really good information in Caneco BT is here the maximum length. I entered a length of 40 meters, but Caneco is telling me the maximum length is 62 meters.
You mean for the short circuit protection?
Yeah, that depends. In this case, it's the voltage drop, the DU.
Ah, okay, DU.
So if our cable is longer than 62 meters, we will get problems with the voltage drop, so we cannot stay in the 4%. Right now we have 3.24.
This 4%, it's these maximum percentages can be set in the software options or somewhere in the project. Oh, okay.
4%. And you can also change it, of course, here in the table.
As before.
The DU maximum or Excel export and import, you know. But
so there are no the software. Okay, of course, but the software itself is not a kind of
presetting.
Yeah.
We have different presettings, but not the voltage drop. You can change here, for example, calculation options. What should happen in different cases, or if I have an MCB or an MCCB or an ACB, what's with the thermal setting? Should it be on the load of my circuit or on the rating of the protection device? What power units do I want to use by default? What's with the protection device? What temperatures do I want to use for the circuit breakers, for distribution circuit breakers, or for switches? What's with the cable? Up to what cross section I want to use a multi-core. So 150 would be single core in this case. Also a few other options here. And we have the preferences, presettings. So here I have different things I can set, like the shortcuts, the ref marks. What ref marks do I want to use, and so on. But the voltage drop is not here in the presettings. It's set it in the standard. And if you want to change it, you can do it in the table.
Okay.
Excel list, I'm sorry. Okay. In this case here, you see the voltage drop is the limitation for my maximum cable length. If you take a look on this board, you see it's IC. So IC is the protection against electrical shock, I think. I'm not sure because of the English shortcut right now, but normally it should be. So if the cable is longer than 113 meters, we cannot make sure that we can switch off in 5 seconds with this protection device. Of course, if I change here, maybe the cross section, if I say I want to use 1.5 square millimeters, we can calculate it again. It's of course purple right now because we cannot consider the 4% of voltage drop of the maximum voltage drop.
Understood.
Okay. So, I don't know, what is there something special you want to see, or?
Most of the times I have to deal with the motors. So MCCs, MCCBs, and variable frequency drives. So I need to know whether the software is handling this type of feeders, calculating the motor's contribution to the short circuit, and so on.
Okay. I created a motor circuit right now, and I just use a standard value for this motor. You see here there's a list up to 500 kilowatt. And I just choose, for example, 45 kilowatt.
But can be forced by hand, or you can put also more?
Yeah, of course. I can also enter here something like this.
Okay.
Calculated, and we see this 46.5 kilowatt have a consumption of 83.8 ampere. with this cosinus phi of 0.88. Okay, so that means that the board will be affected by 83.8 ampere. If I put the cursor here, no, not 83, because you see here 75. Why 75? Because this motor has an usage of 0.9. So it's only to 90% of its nominal value in use. If I put it on 1, we see on the board the consumption of 84. Okay, so in some cases you have two motors in parallel for pumps or whatever, but there is an not parallel, they are in backup. So this or this is in use, but not both at the same time. So the calculation right now would be wrong, because this board has a consumption of 168 ampere, but only one is in use at the same time. So a solution can be to change the usage factor here on 0.5. Exactly. That means that the circuit will be calculated with 100% of the motor load. So the cable has to carry all this power and also the protection device, but only 50% will be delivered to the board above. So if I do it for both motors, you will see here 84 ampere. That's the load of this board right now.
Okay.
You can also enter 0 and 1 if you want. In my case, I have put it here 0.5 and 0.5. Okay. I can take a look on this board, and I will see here in the currents that I have a cosinus phi of 0.88, and I have a load of course 84 ampere, so I can calculate a compensation bank. I don't know if it is the right term in English.
Yeah, understood. Anyway.
Okay. So you have a little tool here to calculate, and you can say, okay, I have a consumption of 84 ampere with a cosinus phi of 0.88, and I want to have a cosinus phi of 0.98 after the consumption, a compensation, I'm sorry. And so we see here we need a power bank with 17.24 kVAr. So I can add this new circuit capacitor bank. That's the right term. And I take a value of, let's say, 20 kVAr with 1 meter of length, because it's in the same board included. And if we calculate it, we will see here on this board that the cosinus phi is right now 0.99, and also the load is lower because we have only 75 ampere regarding the better cosinus phi. So it's from 84 down to 75. Okay, let's take a look on the other board. I create a new circuit, and if we go down, we have these are the standard circuits. Here we have a little special circuit, and here we have a frequency drive.
Yeah.
And this frequency drive, I say here I have a consumption of 45 kilowatt.
This is the consumption of the drive itself, or of the power of the drive or the motor?
It's right now I entered the consumption of the motor. Yes.
Okay.
You have also here nominal values again. I can choose it here. 45. Oh, sorry. 45. It's the 45 kilowatt frequency drive. You can choose your protection device, of course. So it can be an CBD breaker. It can be, I think that's a motor breaker. or an MCCB as you want. I choose a motor breaker for this calculation right now. Okay. And downstream, I add a motor circuit. And on this motor circuit, I choose a protection device none, because it's protected by the upstream protection device of the frequency drive. 45. Calculate. That's it. And okay. So that's a frequency drive in my distribution board with 0 cable length here, and the cable is on the secondary side of the frequency drive to the motor.
And the cable used at the moment for these frequency drives, as I've seen before, it's the normal one, so not screened one.
The cable?
Yeah, the cable type.
Okay.
Is it possible to force it? Yeah, correct.
Of course. Here, do you know the German?
NYCY.
NY.
CY, yeah, NYCWY. Okay, it's the one above.
CWY.
It's okay. Anyway, you have understood. It's okay.
You have these are right now the German cables, but you can enter in the free options also other ones. So if I open this catalog, you will see we have German, France, Nexans. Then we have USA cables. They are included right now. So we have the AWG cross sections. You have Germany, Belgium, Brazil, DTCN. It's for marine standard. We have the Netherlands, Australia, Spain. You also find international and also Italy. DPR and Italy standard. And if I choose, for example, Italy, we can go back to the circuit, and you will find here the cable types for the Italian market.
You were saying that the UL or NEC, you want to call it, calculation is going to be implemented in this software in a later stage, or not really?
Yes. The cables are included right now, but the standard is right now not finished.
When okay, maybe this is a commercial issue, but when it comes, it is somehow
when
that
exactly the standard will be available.
No. Whenever it comes, what happens to the customers that purchased already the software? You get an update, or there is a need to upgrade to the next version of the software? What is your thinking?
Exactly. If the standard is available, it will be delivered in a new software version, of course.
Okay. Any idea of when?
In fact, no. I cannot give you a fixed date right now.
Weeks, months, or years? No, sorry to ask you in detail this, but let's say almost 50% of what we do is related to US, so quite important for me to say, to at least to evaluate. So I was thinking, we talk about months or years?
In the next month, it will not be included, no. No.
Could be by this year.
50% of your projects are for the US market.
Yeah. So without the standard, I will need to force all the parameters, basically.
Excuse me?
Except the cables. Yeah. By not having the standard inside the system, I will have to adapt manually all the rating factors.
Yeah, you can.
Correct.
First of all, here you have the AWG cross sections. You see, if I choose the AWG10, it's 5.26 square millimeters for the calculation. That's a good thing. The second thing, you can on the transformer or on the source, whatever, you can choose
460 also.
Yeah, here the 60 hertz. You can choose a voltage level regarding the US market, and so you have how can I say, the Eckparameter in German. So it's the most important parameter for the calculation. But of course, the standard is different.
Okay. I have a case, some cases where I have a variable frequency drive cabinet. It means one board with many drives. And
yes, okay. Like here we have one board and one drive, and you have.
Yes, let's suppose you have more drives, and during the operation of this project, some of the drives have a contribution in terms of power which is negative. So means they are not consuming, but they are how to say, bringing energy.
They are feeding.
They are feeding the cabinet,
and delivering a short circuit current.
Like a generator. Yes, correct.
Okay.
So how
if we open the source, it's here included. If we open the source, you have here in the additional data the input from motors. If you click here on these three buttons, you will see the present motor consumption in your project is 58 kVA. So, okay. And we can use this 58 kVA, and if we calculate with this value, you will see that the short circuit currents here will change just a little bit because it's not much. But we have here, for example, 10,029. And if I recalculate right now, okay, this value is the same again. I'm sorry, it's the minimum value. The maximum value changed. I just make it backwards. Okay, so you see here the maximum is 39,003, and if I calculate right now with this value, we have 39,249. So the motor input will be considered for the calculation.
Okay, so in this case, what does it mean? It means that you have 58 kilowatt from the motors?
It's just from one motor here, yeah, because the other ones are not calculated. If all of them were calculated, the motor...
because of the drive in between, or?
No, because they were not calculated before, and here we had an factor. We say not both are in use; it's only one each time. No? So also for this value we added here, there was only one motor considered. Because if one motor is rotating and the other one not, I cannot take the short circuit current of both, of course, for the calculation.
Okay. But back to the main bus bar where the drives are connected. In case some of the motors are contributing, this means that this bus bar will not be sized as the sum of all the three drives. Is there any place to indicate that the load in this bus bar is less in reality? I am not sure whether if I explain myself properly. Let's suppose there you have three drives.
Yes.
And these three drives, similarly to the standby pump, they are never running all together.
Okay.
But suppose that when two of them are running, the third one is generating. It's not zero, it's generating.
So you mean two of them are consumers, and one of them motors is a
yeah, it's generating. It becomes a feeder, yes.
okay.
Because by the process, these two motors are somehow running the third motor like a generator.
Okay.
So this means this motor is bringing power back to the bus bar. So that means that the overall, load is less.
So you mean if these two motors are consumers and this one is a feeder, you feed one motor this way?
No, simply I have less consumption on top.
Okay. Yes, of course. You can do. If we go on this board here, we can enter downstream and diversity factor, where we can say, okay, the consumption is maybe 0.6 or 0.66. So it's
okay.
2 motors of the 3 are in use. But you have to, I think you have to calculate for the worst case if all 3 motors are running at the same time. And so for this value, the board has to be calculated, in my opinion. But I don't want to say.
No, it's okay. I just would like to know whether there is a place where to consider this. This is okay.
Okay. So it's possible with this diversity factor.
Okay.
So the power of this board will be multiplied by this factor, and that's the load of the board, of course.
Okay. Clear?
Perfect. You have any other questions?
No, I will say no. The main one.
Okay.
The main one is okay. In case if I have some UPS.
Okay.
For example, sometimes it happens that my main switch, this MSB, for example, is also fed from a diesel generator.
Okay, from a diesel, yes.
And then we have a backup bus bar, so you have a kind of automatic transfer switch.
Okay. So is the genset, yes, the genset, the diesel, supplying in the same main switchboard or in another switchboard and connected to this one?
Can be both cases, but that doesn't matter really. But.
Okay. We add a genset.
Okay.
It's this window here. We can choose what power for the genset. I would prefer 630 or something like this. And we can choose where the genset has to, in what board. We can say in the main switchboard or in one of these boards here. Let's say, for example, in the UV3. Calculate. Okay. And now we have here a new source for the emergency supply. And we can right now give the information to the downstream circuits here that they are supplied not only by the normal source, also by the emergency source. And you will see the difference. This one is normal and supply, and this is only normal. And you see, in this case here, we have short circuit current 22 down to 7.8. In this case here, we have 22 down to 2.3 because the emergency supply is also considered, and the protection device has to be has to have a bigger range.
Okay. Good. So similarly, if I have a UPS,
the same. We can also go here to this board, and we say, okay, downstream we have a UPS, and we can enter the parameters here. of course, we also can use a catalog, an existing one. And because of the motors, I want to prefer a bigger one, not a 10 kVA. Let's say 200 kVA or 250. Okay, that's it. And now we have a normal supply, emergency supply, and UPS supply. And what happens right now is this, that the downstream circuits are looking upstream for the biggest short circuit current regarding the maximum breaking capacity of the protection device. So they check if the biggest current is coming from the UPS, from the genset, or from the Trophos, of course from the Trophos in our case. And the smallest short circuit current regarding the tripping unit will be
out of range.
The UPS right now.
The thing is, it's out of range for him now, for the system.
I did not calculate it, so maybe, yes. So right now it's out of range, you're right. Because we have here a protection device which is tripping at 1170 ampere. But the maximum we can set here is 933 to consider that the protection device can handle the UPS.
So how to change, how to recalculate all of them in one shot, or you have to do one by one, the 3 reds?
Here I choose the model of the protection device by hand right now. So I have to choose one which can handle the 933 amps in this case. For example, this one. I can set it from 300 to 900. Calculate, and it's green, and calculate.
And you cannot ask the system to do the calculation, to recalculate? The red ones?
Yes, but there is so big database protection devices that it's pretty hard for the system to choose the right one. So this is a thing that should be done manually.
Okay.
In this case, the maximum short circuit current is from the Trophos, and the minimum one is from the UPS right now.
Understood. Okay. What other features this software has?
What features do you mean?
Well, I don't know. That's it. I mean, okay, then you have some kind of outputs, I guess, format,
yes,
exports, and so on. Like
exactly. We have a few other things. Of course, if you remember, I put here 250 amps in the distribution board. And maybe it's not correct because here is only one socket, so this socket will not use 250 ampere, of course. So I can calculate my whole project, and here I see the summary of the load on each board. So the UV1 is used with 3.61 ampere, but I am calculating right now with 250 ampere, so I have this availability in percent and in amps, and I can say, okay, for all distribution board, I want to correct this with a reserve or with an availability of 25%. Adjust, and now you can see this is the new change. Okay. Calculate, and right now the software will calculate from downstream to upstream. Okay, that's clear. So we see here in this board right now, they are no longer the 250 ampere, it's only 99 ampere because of the load. The cross section changed and the cable changed. Except if you lock the protection device here, it will not change to the 100 ampere protection device. It will keep the 250 from before, of course. That's a manual lock. The same for the cable. Yes, you have here the selectivity curves on different points in the project. You will see the curves. You also have the cable protection.
Yep.
And the additional results like the breaking time, the maximum breaking time, and so on. You have, like I told before, the possibility to change everything in the table. Here you also can insert new circuits. You can work only in this view if you prefer. And if I change something in the table, I would have the same circuit also here in this view. The third possibility is to use the distribution board view. So you have a network schematic like this one, also automatically created here with our frequency drives and the motors. Okay, and yeah, of course, documentation. There's much documentation here. Begins, of course, with the flyleaves, like this one, where you have the information about your project, your client, project numbers, and so on. You have the possibility to print network single line diagrams from A4 up to A0. They can look like this, because I have here each distribution board on a different document. So that's for the MSB. On the next page, I have the UV1, the UV2, and so on. I can also say here, okay, I want to make all of the circuits on one page. Then it looks like this. You can choose to see the labels, of course. Then it will be something like this. And yeah, you can print it, of course. Then let's go ahead with maybe the conformity sheet. Here you have the calculation results for each circuit. So we have 15 pages for our project here, beginning with the circuit data. That's what we entered. Circuit is okay. That's the most important information. We take into calculation the nominal current, the voltage drop, the protection against electrical shock, and the short circuit protection. And here we have all the calculation results, like the protection device, the breaking capacity. We have the overloads, the voltage drop, the indirect contact with the tripping times for each circuit. We can see all the information here. We have the board single line diagrams in different detail grades. So that's a simple one with a big graphic part and just a little results here. But we also can print something like this, the industrial view with a big number of results for each circuit. Then we will see something like the power requirement. It's interesting for your client so that he can see on which board do he have what availabilities for the normal supply and also for the standby, for the emergency. We have nomenclatures for the cables, for example, where we can see, okay, in what board do we have which amount of cables.
There's a cable list also, I guess. Or?
The same for the protection device. Also a list to see in what board do we have what number of protection devices.
There is a list of cables also?
Yes. It's at the end. I will show it later.
Okay.
Here we have the curve discrimination. I don't know if it's important for your market.
Let's say, yes, selectivity, I would say it is,
yes.
It is important.
Okay. So for each circuit,
is by each circuit breaker, yeah. Okay.
Yes. Then we will see here, where is it? Cable list. And in this cable list, you see, okay, we have, okay, it's a little different, but okay. There is one consumer. It's a little bit different than the German one for the row, but it's possible to change it. It's this ref mark, so the UV1 will be supplied by the MSB. We have this cross section with this cable type, this length. That's the maximum protected length of the cable. And maybe here a description, something like what will be supplied by this board, or some notes you want to enter.
Is it possible to give a number to each cable somewhere, or?
It's possible that you do it by yourself or automatically. So here you see cable. It's already filled by W002. The next circuit has the 003, I guess. Yeah, exactly. That's in my pre-settings.
But in the table, okay, go ahead.
Okay, you can change it here. The cable has, in my case, only a W and a number that's continuing. But you also can enter the W after the distribution name. So if I make this and I rename it again, that's necessary. So I rename the cable ref marks for all. Okay. It will be the cable MSB W02. Okay. And it's possible also to make this information visible in the cable list. So it's just necessary to enter the column here. I hope that I find it in the English version. Just a moment. Cable. Ref mark. That should be the right one.
Yeah. The second column looks like.
No, it's not the right one. Yeah, it's the wrong ref mark. I choose the wrong. It's the same again. You see it here. I don't need this ref mark. I think it's somewhere like here. I don't know the parameter in English, so that's ref mark. I don't find it right now.
Okay, but the software itself, it's also handling the terminal strips and creating some terminal diagrams of the cabinets, or?
What do you mean?
You know, this is a cable list, so without showing the wires and where each wire have to be connected. Maybe this is not the purpose of this software.
To see the distribution board and to see every wire in the board, you mean?
Yeah.
No.
Or let's say the cable going out where has to be connected, but.
You mean
the terminals?
This terminal here.
Yeah.
Okay.
Yeah.
Yes, you can go to the preferences, and in the preferences you have the possibility. I hope it's in the preferences. No, I'm sorry. It's in the calculation options, cables, and you can see here the maximum cable cross section on terminals. So all cables up to 35 square millimeters will be connected to terminals. All cables with a bigger cross section will have no terminals. They left the distribution board directly from the protection device. And it's possible to rename the terminal and to display them also. Yeah. It's a little bit small, but I make it a little bit bigger. You see here, it's X001, terminal 1 up to 3.
So on the cable list again, I will see I could add the sourcing terminals in the cable list.
You can add the cable list also this value, yes, right.
Okay.
But I'm pretty sure I will not find it right now.
No, it's okay. But in principle, the data is there, so why not? It should be just.
Yes, exactly. It's there. And you can also choose on this circuit here, if I make a double click on the circuit in the additional data, you see here on the terminal block name, you can change it if you want from X001 to something like this, XY. And the terminal numbers, I can enter it by myself, or I do it automatically. Right now it's the XY123, or I say rename it again. So it's the 1 up to 3. That's the automatic.
Why it's red now? Okay, who knows? How you know now why it's red? Sorry?
Excuse me?
Why it is red now? How you know?
Because it's not calculated. Circuits to be recalculated.
Okay.
Green means everything fine.
Clear.
It's compliant to the standard. Red is not calculated, and for example, if I move the cross section to a lower one, it's non-compliant. That's purple. But you can change the colors in the presettings. So if you prefer black, you can change it to black or whatever.
Good.
So what do you think?
Sounds good.
Perfect.
Sounds good. Yeah. Let's have a quick look to the HT.
Okay. The HT is a little bit different.
I tell you, for me it is interesting only to calculate from the medium voltage switchgear to the secondary of the transformer. not on the high tension
Okay.
side. So this area you can simply forget.
Yeah. Okay. Good. I will not create a new project right now. Let's take this one. Just to show how it's working, you have here the library of symbols, and you can add new symbols if you want. And if you take, for example, a transfer like this, you can move it, you can place it wherever you want, and you can connect it here with a cable to the board, and from the board to the next board, like this. And for example, if I make this board a little bit longer, you will see, okay, this trafo is connected right now in a good way, I think. You can move it later. That's not a big problem. To enter the information, it's a double click, and you see here all the information for the trafo. It's the German version right now, so I cannot give you the English overview. But you can see that you have also catalogs. You have Alstom, DIN, or Schneider, and you can choose it's a trafo with, for example, 20 kV on the primary and 410 volt on the secondary side, with a power of 1.6 MVA, and the rest will be done automatically. Okay, so I delete it. We don't need it right now. Okay. So here it's possible to create Varianten. To say in my setting A, all these elements of my network are active. In the B, all them, C, D, and E. And there is also a visibility for it. So black, the active network elements. In red, the non-active ones. And the standard configuration for my calculation is only the my network from the supplier. The generator, the diesel is not in use. In my variant B, the diesel is in use, but not the supplier one. In C, this transformator is not in use and the ring is open, and so on. And all these variants will be calculated in one calculation. You can define up to 8 different variants in one. And okay, let's make a short calculation. So project, all calculations for all variants. Okay.
If in case I'm calculating the medium voltage distribution and the transformers with the HT, the short circuit values out of transformers need to be typed into the BT manually, or there is a link between HT and BT?
There's no link. No. You have to enter it manually. Okay, so we see here right now the calculation results for our HT project. We have here a list of all elements in our network, or maybe with a commentary. We see here all the cable types we are using and all the connections in our project. So beginning here, and it's go ahead on the next slide. So we have here N2, XS2, and so on. It's a connection between my 20 kilovolt NOT and the station 1 with a length of 380 meters and so on. We have a few connections here. Here we have our synchron genset with the values. We have all the trafos in our project, also with the values, the motors, and on the next page we see the variants and also the checklist, what element is active in which variant. On the next page, on the page 6, the results, the calculation results are beginning. And you see here variant A, B, and so on for the next pages. And we have here the 3-pole symmetric short circuit currents. So we see, for example, the results for the NSHB, for the main switchboard, it's 45 kiloamps. In B, it's only 21 kiloamps. In the variant C, it's 43, 43, and in E, we have 45. So we have different variants in the main switchboard, and this short circuit current we can use regarding the calculation in Caneco BT. To
type in there.
Exactly. The next one is the unsymmetric short circuit current, so it's the IK2. You have a question?
No, just finish. Then after.
Okay. On the next page, it's the unsymmetric again. Then we see here the power, the short circuit power on the nodes in our network. The MVA, also important for Caneco BT for the calculation. Then we have the cross-section calculation for the cables regarding the current carrying capacity. So cable 8, for example, is a connection between the 20 kilovolt node and the station 1. Needs a cross-section of 50 square millimeters to transport the 100 amps. So that's the first calculation we are doing. What cross-section is needed to deliver the amps? The second calculation is the calculation regarding the thermic stress. So we have protection devices in our network, and the protection devices have a releasing time of 500 milliseconds or 100 milliseconds. And for this time, the cable has to carry the kiloampere, the I squared T value. I'm sorry. And to deliver this value for 500 milliseconds, we need a calculated cross-section of 37.7 square millimeters. That's why the software is using a 50 square millimeter cable. So these two checks will be made. The current which is carried and the thermical stress on the cable. And Caneco is using the bigger value, of course.
Clear.
Then we have here a cable list with the results. So cable 8, 50 square millimeters, cable 10, 400 square millimeters. Okay, and that's it. That's the calculation results of Caneco HT. It's also possible to create a voltage drop report, so we can see what voltage is on which element in our network available. And we can display all these results in this graphic. So I can say I want to see my results for variant A, for example, on the nodes of my network. And okay, you see here on each node, on each of these lines here, we have right now the results for the IK3 max.
I don't see, maybe yes, maybe not. Can you also handle power factor correction at the medium voltage side with Caneco HT?
Power factor correction.
Yeah, what you did before with the BT to introduce some capacitors on low voltage side before you did it for BT.
Ah, okay. To take care on the cosinus phi, you mean?
Yep, on medium voltage side.
So we have here the cosinus phi on this motor, of course. And here you have the condensator bank. And yes, it's
D and Y.
or a Y condensator, yeah, whatever you need in this case. And you can
put it online.
Exactly. Yes,
okay.
It's a complete different philosophy. BT and HT, they are really different. But I think it's necessary that in HT it's like this, so you can move everything. You can say, okay, I want to place it a little bit down to have more place above and so on. It's really important for the HT networks. In the BT, maybe not, because it's a clear structure, but in the HT you have ring and so on.
No, it's okay, yeah, but at the end there's less things to be care in the HT. Yeah, normally you have less stuff to handle. So.
Yeah.
Understood.
And the third software solution is the Caneco TCC, of course. I show you the Caneco TCC also. It's only the time current curves. So we can create a new paper in different voltage levels. You see here up to 225 kilovolts and let's say 400 volts. I want to include, for example, a fuse. So I have the curve of this fuse here, and it's a 1000 ampere fuse. Let's say, okay, it's a 1000 ampere, maybe. I also have a protection device like a switch. We have all the manufacturers also in Caneco TCC, so you can choose from the different catalogs. And maybe I have an MCCB with, let's say, 630 amps.
What's the purpose of TCC in principle?
Excuse me?
What is the purpose of this software?
To have a selectivity overview without any calculation. So it's not necessary to create a project like in Caneco BT to have an overview about my selectivity curves. I can do all of this stuff here.
Yes, more or less just to check, could be to check existing status or something like this.
Yes, exactly. And one important point is in Caneco TCC we can mix up the voltage levels. So I'm here at the low voltage, and I can say, okay, I want to see also a trafo curve, maybe, and I want to insert also an high voltage fuse, maybe 24 kilovolts, to see how is all this stuff working together.
It's just by luck that you're fine, or are you selected?
I'm sorry, I did not understand.
It is just by luck that it looks okay, or you have then now a check, a kind of calculation check, whether it is.
No, it was luck.
Okay.
I just choose a few different things, and I'm a lucky guy.
Yeah, it looks like it.
Yes.
Okay.
Yeah, you also can enter here, for example, a motor starting first, if you want to, and let's say 400 kilowatt, or it's too much, let's say 300, and we see, okay, this protection device from ABB, the green one, and this motor here, they are fitting together. You because the current is under the curve at each time. But of course, just.
But I mean, it's just a visual check, or the software itself has also a kind of back.
No, it's just a visual check.
Just a visual check.
Just visual. Yes.
Mm-hmm.
But it's maybe, in my opinion, it's a good thing because I can change here the settings. I see, okay, if I move the mouse here, it's possible from 3 up to 10.5 seconds. So let's check 3 seconds. Okay, would also fit. Yeah. So you see in a very fast way what settings can I use in this constellation, and you get also a list of settings. So this protection device is set it on these values. So it's a good thing that the TÜV in Germany is using this software, because if they have to check an existing system, existing facility, they use Caneco TCC. They go to the main switchboard. They say, okay, this and this protection device are in use. So they choose it here, and they see in a pretty fast way, does it make sense? Is it possible to get selectivity in this case or not? So that's why the TÜV is using this software.
Yeah, this is more for existing plants. And yeah, okay, understood. This is maybe not really interesting for me.
Okay. But you have seen it.
Yeah, sure. Thank you very much. Thank you very much.
Yeah, no problem. You're welcome. That's why we are talking together.
Good. Good. I think, yeah. I think it's okay.
Okay, Thomas, thank you very much. It's very interesting for me.
No problem. You're welcome. You're welcome.
Yeah,
I think all the further steps you will do with Giuseppe Badil. And from my side, it's okay right now. If you have any further questions, just let me know, or just talk to Giuseppe Badil, and we will do another session or whatever. But I think for today we had enough information.
I'm just thinking, what about the training? Is it the training, Giuseppe, done in Italy by somebody from Italy, or how it is? We never talk about that.
In English, from Germany.
It will be him again. It's fine. It's good. Okay, good. Okay.
Okay.
Thank you, Thomas.
Thank
you
you
very much.
Okay, no problem. Welcome.
Thank you.
Have a good Friday and a great weekend.
You too. Thanks. You too.
Until next time. It was a pleasure for me. Bye-bye.
Me too. Okay. Thank you very much.
Okay,
Bye-bye.
Thomas, see you later. Bye. Bye-bye.
See you. Bye-bye.
Fabio, mi senti ancora?
Sì, ci sono.
Ecco, grazie mille per il tuo tempo. Abbiamo purtroppo
grazie a voi.
un'altra dimostrazione che comincia adesso fra minuti, sempre con Thomas, con un'altra...
Ci salutiamo.
E niente,
okay.
Spero che vi sia piaciuto, che perlomeno di aver risposto a tutte le domande, e immagino che state valutando anche delle altre opzioni.
Veramente no, però okay. Dai, ci risentiamo, approfondiamo quando sai più con calma.
Sì, no, ecco, dicevo che io avevo già preparato un preventivo, se non ricordo male, e avevo già applicato un po' di sconto su Caneco HT, e ecco, dicevo che eventualmente se ci fosse qualche problema per il prezzo posso provare a chiedere un...
Devo riprendere in mano un attimino, adesso ho capito che comunque quantomeno la parte HT può essere tendenzialmente interessante, perché completa un attimino quelle che sono le mie necessità. Okay. Devo vedere un attimo, adesso vado a rivedermi l'offerta perché è passato un po' di tempo, quindi
Va bene, va bene. No, dicevo che se state valutando anche delle altre offerte, se il problema è il prezzo, si può cercare eventualmente di rivederlo. Se c'è, non si applica.
Sì, ho capito il messaggio, ho ricevuto.
Non si applicano di solito sconti, però siamo nuovi in Italia, stiamo cercando di farci conoscere e di farci volere bene. Ecco.
Ok, capito, d'accordo. Grazie.
Grazie, a presto, buona giornata.
Alla prossima altrettanto.
Ciao.
Ciao.